What's up, folks? Welcome to our coding series. Now we're getting to our 11th episode, so now focus on question 11. Let's look at the question. Which two options will place a barrier across all qubits to the quantum circuit below? So now we have a quantum circuit, QC, which is equal to quantum circuit, parentheses 3,3, and we have 5 options. Before getting into the question, let me explain what is a barrier. So firstly, I need to import a package, including transpiler here. So what is a transpiler? So transpiler is to optimize our performance in the circuit. So when we implement more and more gates into our circuit, it becomes more abstract in the level. But this quantum circuit may not be implemented into the hardware. So what should we do? We need to have a transpiler. By doing the transpilation, the specific backend can implement the quantum circuit directly within the hardware limitation. So let us now implement our backend. Firstly, we load our account, extracting from the IBM Q experience, and then we call the backend provider. This time, I want to use IBM's Oslo, which is located in Oslo. After that, let us run the example. So when we have two hammer gates operate together, which is equivalent to the identical gates, when we have the transpilation, we only have nothing. But with the barrier put in between them, after the transpilation, we can see that the hammer gate is being decomposed into 3 gates, 2 LZ gates and 1 square root X gate. So what does it mean? We place barrier across quantum circuits, which can be put between the input state and the operation, or between the operation and the measurement. So barrier operation is the instruction to the transpiler to separate parts of the operation. By doing this, we can measure some noises introduced by the gates. Now we observe QC2. On the left hand side, we have 2 timer gate. On the right hand side, we have X and H gate. As we know that 2 timer gates put together, we have identity gates. But on the right hand side, we see that it's a transpilation when we put the barrier in between. To give us some practical application, so when we have a T1 experiment, transpilation can help to find the coherence time by measuring the relaxation time of the qubits. By putting many identity gates in state 1 and observe when it comes to state 0. So the barriers can respect all this as an individual, unique, single qubit gate. So let us now back to our question. We have QC is equal to quantum circuit 3,3, which means that we have 3 qubits and 3 classical bits. In option A, it generates an error. The command is that qc.barrier parentheses QC. So what it means is that we put all the quantum circuit as a whole into the barrier. So it is a syntax error. We cannot put the whole circuit into the barrier, but only in a specific qubit into it. So let's see option B. So we see that the command is that qc.barrier parentheses 0, 1, 2. So what it means is that we put the barrier in these columns, Q0, Q1, and Q2. So when we call qc.draw, we can see that the diagram is shown here. Let us run option C. This command also works, qc.barrier parentheses without anything there. So what it implies that we put the barrier in all qubits. So why we can see 2 barrier because we call it 2 times. So what's the problem with option D? We do not have qubit 3. We only have 0, 1, and 2. Remember how we count qubit. And what is the problem with option E is that we don't have this kind of command, qc.barrier underscore all. So remember how we call the barrier. It's very important how we do the experiment in the practical application and during transpilation. That's it for today's tutorial. If you have any question, please comment below. If you find this tutorial is helpful, please like, share, subscribe our channel. We are QuantumGrad. Please support us. Ciao. Ciao. Ciao.